Data center exploration physical mode. Data centers are often referred to as the brain of an organization, storing and analyzing data, providing communications both internally and to clients, and providing the tools necessary for research and development activities. The data center must be constructed in such a manner that it can securely and efficiently provide its full range of products and services regardless of what catastrophe occurs. There are many different systems that go into the construction of a data center, but for this activity we shall concern ourselves only with the networking components. Data centers can range in size from only a few servers to housing hundreds or even thousands of servers. Whatever the size, the data center must be constructed in an extremely organized manner to simplify management and troubleshooting of a complex environment. Another design characteristic is to make the data center more robust by using redundancy to eliminate any single point of failure. This could involve adding extra devices to provide physical redundancy and/or using technologies such as First Hop Redundancy Protocol (FHRP) and link aggregation to provide logical redundancy. In this packet tracer physical mode, most of the devices in the Toronto and Seattle data centers are already deployed and configured. You have just been hired to review the current deployment and to expand the capacity of the data center 1 in Toronto. Explore the characteristics of a small data center. Explore physical layout. How is the branch office physically connected to the data centers? Okay. On the left, you have data center number 2 is Seattle. On the right, Toronto, data center number 1, and Winnipeg on middle. Winnipeg is the branch office, but double click on Seattle. Now you can see this is the building, data center 2. That's why I said Seattle data center 2. Click here, back level. Toronto, double click. Data center 1 is in Toronto, so that's why I said Toronto data center 1, back level, and click on Winnipeg. The branch office building is in Winnipeg. But the question is, how is the branch office physically connected to the data centers? Now you can see, okay, back level, you can see 2 fiber connections. From Winnipeg, one goes to Seattle and another fiber goes to Toronto. Okay, and cable type is fiber, cable length 4,956 meters. Okay, and double click on Winnipeg. Click on branch office building. Click on wiring closet on branch office. And you can see the edge router on branch office and 2 switches. Edge router has 2 connections. one connection to DC to A router, okay, from Edge router, that is this router, and this connection goes to DC to A router. DC2 belongs to data center 2, so is data center on Seattle. Okay, this another connection goes from this edge router and goes to DC1A router, and DC1 belongs to data center 1 on Toronto. Okay, DC1A router placed on Toronto. So how is the branch office physically connected to data centers? The branch office is connected through redundant fiber links to the data centers. The branch office edge router connects to DC1A router on data center 1 on Toronto, and also edge router connects to DC2A router placed on data center 2 on Seattle, providing a redundant connection from the branch office to the data centers. What logical configuration in the branch office provides redundancy? Okay, click on the edge router, click here, command line interface, enter enable show running config to view the configuration of this router, and now you can see these static routes. These static routes, the destination is 172.16.0.0 and goes through this NetHub IP address, but by default the metric is 1 for this, and this another static route that is a floating static route, the same destination 172.16.0.0, use another NetHub IP address, and the metric is 10. Okay, the same way with this another destination static route and floating static routes, the same configuration with this another destination, and if this is the preferred link, and if the link of this static route fails, the floating static route will take place. Okay, what logical configuration in the branch office provides redundancy? Redundancy is provided with floating static routes on the edge router to data center 2 if the main link to data center 1 fail. How is data center 1 connected to data center 2? Okay, back level, and you can see this black cable. Okay, between Seattle and Toronto. It's a black cable, but the cable type is fiber. So take a look, go to Seattle, double click, data center 2, data center 2. Okay, This connection goes to edge router. This connection goes to DC1B router. So DC1 is placed on Toronto. Data center 1 is Toronto. This another fiber goes to DC1A router. So is DC data center 1 on Toronto. This another cable goes to DC1A router. Is data center 1 on Toronto. And this fiber goes to DC1B router, data center 1 on Toronto. Okay, back level. And click on Toronto, data center, data center. This is connection to edge router. Okay, this goes to remember you are on Toronto data center 1, so this cable goes, so in this case the destination is DC2B router placed on data center 2, it's placed on Seattle. This fiber goes to DC2A router, data center 2 on Seattle. The destination in this case is DC2A router, the data center 2 in Seattle, and this cable goes to DC2B router, data center 2 in Seattle. How is data center 1 connected to data center 2? Data center 1 and data center 2 are connected through redundant fiber links. DC1A router connects to DC2A router, and DC1B router connects to DC2B router. How are the devices in data center 1 physically organized? Okay, this is Toronto. This is data center 1 placed in Toronto. Enter here again. Now you can see rack 0, rack 1, rack 2, rack 3, 4 racks. And now you will see the redundant links between switches, the connections between switches with redundant links, two connections, also the connections from switch to router using redundant links, and also the connections to the servers with redundant links. Okay, two connections. How are the devices in data center 1 physically organized? The devices are organized in an extremely logical manner into redundant racks, so if any rack fails, the redundant racks can compensate. One of the main design features of the data center is to standardize on equipment layout so that you have a flexibility and are not limited by equipment layout. Thus, the data center 2 equipment layout differ from data center 1. Okay, back, back, back. Click on Seattle, data center 2, click. Okay, the same configuration, the same layout. So the answer is no. Data center 2 follows the same principles as data center 1 for equipment layout. Why is the physical organization of the data center devices important? The clear and consistent layout of redundant physical devices helps with data center flexibility, troubleshooting, and management. A logical equipment design prevents the equipment layout from limiting the usefulness and efficiency of the data center. Explore the naming and addressing conventions in both Data Center 1 and Data Center 2. How are the devices named on the data centers? Okay, for example, in this case, this is rack number 1, and this is DC2. This means data center number 2, rack 1, and this is switch A. This another is data center number 2, rack 1, switch B. This is data center 2, rack 1, server 1. Data center number 2, rack 1, server 2, and so on. For example, data center number 2, rack 2, switch A, and data center number 2, rack 2, switch B, rack 2, switch server 1, rack 2, server 2, rack 2, server 3. So how are the devices named in this data center? Devices naming in the data centers are based on the physical location and function. How are the devices addressed in the data centers? For example, click here on this server, on server rack 1, server 1, click here, desktop, and now you can see the IP address, but focus on this third octet. Okay, first octet, second octet, third octet is 11, and rack 1, server 1. Click here on this another server, 172.30.12.1, rack 1, server 2. Click here, rack 1, server 3, and so on. Go to rack number 2, the third server, rack 2, server 1, rack 2, server 2, rack 2, server 3, and so on. And goes to rack 0, third server is 1, rack 0, server 1, rack 0, server 2, rack 0, server 3, and so on. How are the devices addressed in the data centers? Device addressing is logically based on physical location. For example, servers have the rack and position number as part of the IP address in the third octet. So one can identify the location of the server. Rack 0 is a multi-purpose rack serving as the network substation, so the servers follow a slightly different addressing scheme to allow for the required networking equipment. Why is the naming and addressing of the data center devices important? Data center flexibility, troubleshooting, and management are improved by the logical layout of device names and addresses, as well as the physical placement of the devices. A logical naming and addressing scheme allows for future growth and does not place undue limits on the data center flexibility. Explore data center redundant layer 2 technology. Examine DC1 Rack 0 switch A and DC1 Rack 0 switch B. Okay, I am in Seattle, so go back. So DC1 is on data center 1, placed on Toronto. So click on Toronto, data center 1, data center 1. Navigate to data center 1 server room, and Rack 0, DC1 Rack 0 switch A, command line interface, and DC1 Rack 0 switch B, command line interface. Okay, click here on data center 1 Rack 0 switch A, click here, command line interface. What technology is used to provide redundancy and stability in their configuration? Enter, enable show running config, space. Okay, you can see port channel 1, this is an Ether channel, and channel group 1 on Fast Ethernet 1 and channel group 1 on Fast Ethernet 2. So Fast Ethernet 1 and 2 are forming the port channel 1. Okay, Fast Ethernet 1 and 2 are part of port channel 1. Because of this, channel group 1, channel group 1. And passive keyword is the LACP configuration. This is an Ether channel using LACP. Also, you can verify this show Ether channel summary. Now you can see port channel 1, protocol LACP, ports Fast Ethernet 1 and 2. So the answer is the switches use Ether channel configured with LACP. And what is the purpose of this technology? This technology allows multiple physical links to function together as a logical trunk. This combines the link bandwidth but also provides redundancy if one of the physical links fails. What is the total bandwidth over port channel 1? Okay, click here again on DC1 Rack 0 switch A. Fast Ethernet 01 runs at 100 megabits per second. Fast Ethernet 2, 100 megabits per second. So port channel 1 will run at 200 megabits per second. Ether channel bundles multiple physical links into a logical channel. In this case, it is bundled to 100 megabits per second links into 200 megabits per second Ether channel bundle. What will happen if the Fast Ethernet 01 port on DC1 Rack 0 switch A fails, and why? Okay, click here again on the switch. If DC1 Rack 0 switch A Fast Ethernet 1 fails, The connection to DC1 master switch A will remain active using the other link in the bundle, DC1 rack 0 switch A fast Ethernet 2. Okay, if fast Ethernet 1 fails, fast Ethernet 2 still remains active. Now you can see the connection from this switch to the DC1 master switch. The connection from DC1 rack 0 switch A to DC1 master switch with redundant links. Explore data center redundant layer 3 technology. Examine DC1A router and DC1B router. Okay, these routers, DC1A router, DC1B router. From rack 0, DC1A router command line interface, DC1B router command line interface. Okay, on rack 0. Okay, click here on DC1A router command line interface. What technology is used to provide redundancy and stability in their configuration? Now you can see HSRP messages, HSRP logs, hot standby router protocol, enter, enable show running config. Fast Ethernet 00 and on Fast Ethernet 10 you can see standby configurations, or also you can use show standby, enter, space. Now you can see Fast Ethernet 00 and Fast Ethernet 10 configured with standby. The data center routers are configured using FHRP, called Hot Standby Routing Protocol, HSRP. What is the purpose of this technology? This technology is used to provide redundant default gateways if part of the physical infrastructure fails. Which router and interface will be used as the default gateway for the 172.16.00 prefix 16 network, and why? Now you can see this default gateway is the virtual IP address will be the default gateway 172.16.0.254. And on Fast Ethernet 0, this router, DC1A router, is active. The default gateway for 172.16.00 prefix 16 network is 172.16.0.254. HSRP is configured with a priority of 100 on the DC1A router Fast Ethernet 00 interface. So this is the active interface. Okay, active interface, priority 100. Fast Ethernet 00 DC1A router goes to another router, DC1B router, command line interface, enter, enable show standby, space. Fast Ethernet 00 priority 50. This is the standby router, the same default gateway. The DC1B router fast Ethernet 00 is configured with a priority of 50, so it is the standby interface. Which router and interface will be used as the default gateway for the 10.16.00 prefix 16 network and why? Okay, click on DC1A router. Okay, fast Ethernet 10, this is the standby interface, the standby router. Virtual IP address, the default gateway 10.16.0.254. The priority is 50. The DC1A router fast Ethernet 01 is configured with a priority of 50, so is in a standby state. Go to DC1B router fast Ethernet 10. This is active. Virtual IP 10.16.0.254. Priority 100. The default gateway for the 10.16.0.0 prefix 16 network is 10.16.0.254. HSRP is configured with a priority of 100 on the DC1B router fast Ethernet 10 interface, so it is the active interface. Create a plan for expanding the current data center. Determine what equipment is required to add one new rack of equipment to both data center 1 and data center 2. From your review of the two current data centers in part 1, determine the equipment required to add a new rack of equipment to data center 1. Okay, data center 1 is Toronto. When scaling the infrastructure of a data center construction, it is important to standardize construction and configuration whenever possible. What new switches are required? How should they be connected? What should their names be? Okay, I am on Toronto data center 1, so that's why my devices starts with DC1 data center 1 on Toronto. The switches on the racks are connected to the master switch A and master switch B. Okay, so I will add the switches. Okay, on the shelf you have two 2960 switches, so drag the devices. The first switch, and the second switch. Okay, name the switches just like this. DC1 rack 5, switch A. DC1 rack 5 switch B. Okay, what new switches are required? How should they be connected? What should their names be? The current equipment racks all consist of two Cisco 2960 switches connected to the master switches in rack 0. For consistency, name the switches DC1 rack 5 switch A and DC1 rack 5 switch B. These switches are connected back to DC1 master switch A and DC1 master switch B. So how are the rack 5 switches connected to the rack 0 switches? Look, the another switches are using fast Ethernet 1 and fast Ethernet 2 to connect the switches on rack 0. Fast Ethernet 1 and fast Ethernet 2. Fast Ethernet 1, fast Ethernet 2. And if the switch is A, connects to master switch A. If the switch is B, connects to master switch B. On DC1 master switch A, you can see ports 23 and 24 free ports. On DC1 master switch B, you can see ports 23 and 24 free ports. I will use this copper straight through cables and connect fast Ethernet 1 on DC1 rack 5 switch A to port 23. Okay, very good. Now another cable to connect fast Ethernet 2 to port 24, but I am unable to connect port 24. I can't see the port, so you can do the following: right click on the switch and use manage all cables on the device. Wait a moment. Now this is very good, so try again. Use the cable from fast Ethernet 2 to fast Ethernet 24 on DC1 master switch A. Okay, and right click on this another switch on DC1 master switch B, manage all cables on the device. And connect fast Ethernet 01, fast Ethernet 023, fast Ethernet 2, fast Ethernet 024, How are the ROC 5 switches connected to ROC 0 switches? DC1 ROC 5 switch A ports Fast Ethernet 1 and 2 are connected to DC1 master switch A ports 23 and 24. DC1 ROC 5 switch B ports Fast Ethernet 1 and 2 are connected to DC1 master switch B ports 23 and 24. The links from DC1 ROC 5 switch A to ROC 0 master switch A are bundled together, and the links from DC1 ROC 5 switch B to ROC 0 master switch B are bundled together and will use LACP Ether channel bundle. How many servers should be added to ROC 5? How should they be configured, and with what addresses? Okay, so look at the ROC number 4. You have 1, 2, 3, 4, 5, 6 servers. So add 6 servers. Okay, so add the 6 servers. Okay, and name the servers. You are on Toronto, so it's data center 1's DC1-R5 ROC 5 server 1. Server 2, server 3, DC1 R5 server 4, 5, and DC1 Toronto data center 1 ROC 5 server 6. Okay, the names. So take a look on the interface cards on this server. I think they are Fast Ethernet cards. So they are Fast Ethernet interfaces. Click on the server on rack number 2. They are Fast Ethernet interfaces. Fast Ethernet 0, Fast Ethernet interfaces. Okay, so go to rack 5. Okay, only one interface, and add physical mode. When I click on this interface, fast Ethernet interface, this PD host NM1CFE, PD host NM1CFE module, fast Ethernet interface, place the device. The another server. Okay, click here. Okay, the 6 servers with 2 fast Ethernet interfaces, each one. How many servers should be added to rack 5? How should they be configured with what addresses? To maintain consistency with the existing data center, a total of 6 servers should be added to rack number 5. These servers should have 2 fast Ethernet network interface cards, and these interfaces should be configured with IP addresses, and the third octet of these IP addresses will be the first number with the number of rack, and the second number the number of the server in the third octet, and the default gateway should be the virtual IP address of the HSRP configuration, the hot standby routing protocol, and the DNS address should be the same as the other servers. How should the servers be connected to the network? Okay, look at the rack number 4, how the first interface on the first server is connected to fast Ethernet 13. The second interface is connected to fast Ethernet 13 on switch B. For the next server, the connection is to fast Ethernet 15 on switch A, and the next interface connected to fast Ethernet 15 on switch B, and so on. And go to the rack number 5. Use the cable, connect the first to switch A 13. Okay, the second interface to switch B 13. This fast Ethernet on the second server to 15, switch A. The another connection to second interface to 15 on switch B. Okay, and so on. Okay, very good. How should the servers be connected to the network? To maintain consistency with the existing data center, RAC 5, server 1, fast Ethernet 0 should be connected to DC1 RAC 5 switch A fast Ethernet 13, and RAC 5 server 1 fast Ethernet 1 should be connected to DC1 RAC 5 switch B fast Ethernet 13. And RAC 5 server 2 fast Ethernet 0 should be connected to DC1 RAC 5 switch A fast Ethernet 15, and RAC 5 server 2 fast Ethernet 1 should be connected to DC1 RAC 5 switch B fast Ethernet 15, and so on. How would the above information change for adding a new rack to data center number 2? In data center number 2, device names should be contain DC2 instead of DC1. Okay, in rack 5 and servers 1 to 6. Configure the data center devices to expand the data center capacity. You will install and configure the equipment for the new rack in Data Center 1 Toronto. Install the required equipment in rack 5. Drag 22960 switches to the top of rack 5. Okay, ready. DC1 rack 5 switch A, DC1 rack 5 switch B. Drag 6 servers. Ready. 1, 2, 3, 4, 5, 6. Click the first server in rack 5 and under modules, click and drag the second PD host NM1 CFE. Okay, ready. All servers with 2 fast Ethernet interfaces. Click the power button below the second interface. Okay, turn on power on the servers. Click here. Click here. Here. Okay. 6 servers. Click the config tab and set the display name DC1-R5S1. Okay, go to the first server, click here, and config tab. Use this display name. Very good. Is the same I use it here. Repeat for the other 5 servers, S2, S3, and so on. Okay, ready. S2, server 2, S3, server 3, and so on to server 6. Ready. Configure IP addressing for the servers. What is the fast Ethernet 0 default gateway and DNS address for all the servers in data center 1? Okay, and review another rack, for example, rack number 4, and review the configuration of first interface. Okay, for example, on this server, DC1 R4 server 1, rack 4 server 1. Click here, go to config, and go to desktop, go to IP configuration, and select fast Ethernet 0, and look at the default gateway 10.16.0.254 and DNS 172.16.1.1. Okay, but this should be 172.16.0.254. Okay, I repeat, this is an error. This should be 172.16.0.254. Because the default gateway should be in the same network as the IP address. And look at this, they are on different network. And if this is 172.16, this should be 172.16. Okay, so this is an error. 172.16.0.254. Okay, the default gateway should be 172.16.0.254, and the DNS server is 172.16.1.1. On the same server, review the fast Ethernet 1. Okay, another interface, the second fast Ethernet interface. The default gateway is 10.16.0.254. This is okay. The default gateway is placed on the same network of the IPv4 address. Very good. Okay, this is okay. The default gateway is placed on the same network as the IPv4 address. And the DNS server is 10.16.1.1. Very good. Look at another example. Go to rack number 3 and review rack 3 server 1. Go to desktop, IP configuration, fast Ethernet 0. Okay, the default gateway is incorrect, should be 172.16.0.254. 172.16.0.254 and DNS server 172.16.1.1. Review fast Ethernet 1. And the default gateway 10.16.0.254 and DNS server 10.16.1.1. Okay, this is very good. Okay, what is the fast Ethernet 0 default gateway and DNS address for all servers in data center 1? Okay, the answer is the default gateway is 172.16.0.254 and DNS is 172.16.1.1 in all fast Ethernet 0 in the servers. What is the fast Ethernet 1 default gateway and DNS address for all servers in data center 1? The answer is the default gateway is 10.16.0.254 and the DNS is 10.16.1.1 in all fast Ethernet 1 interfaces on the servers on data center 1. In conformance with the addressing scheme of servers in rack 0 through rack 4, complete the following addressing table for the servers in rack 5. Okay, for example, on rack 4, server 1, the DNS server is 172.16.1.1 for fast Ethernet 0. Fast Ethernet 0 should be the same on rack 5. On rack 5 servers 172.16.1.1. Okay, for all fast Ethernet 0s, and the DNS for fast Ethernet 1 on a server on rack 4 10.16.1.1. On fast Ethernet 1 on all servers on rack 5 the same 10.16.1.1. The same for all fast Ethernet number 1. And the default gateway for fast Ethernet 0. Okay, remember this is incorrect, should be 172.16.0.254. This is a rack 4 server, but on rack 5 server, the default gateway for fast Ethernet 0 should be 172.16.0.254. And use the same for all fast Ethernet 0s on servers on rack 5. And for this server on rack 4 on fast Ethernet 1, the default gateway, this is very good, 10.16.0.254. 10.16.0.254. Okay, for all servers also on rack 5. Okay, this is the first. And remember, on the example on this server on rack 4 server 1, look at this fast Ethernet 0, 172.16 rack 4 server 1, 41. So for fast Ethernet 0, the IP address should be 172.16 rack 5 server 1, 51, in use number 1. Okay, use number 1. The same subnet mask and review fast Ethernet 1 on this server on rack 4, IP address 10.16 rack 4 server 1, that one, and the same subnet mask. For fast Ethernet 1 should be 10.16 rack 5 server 1, that one, the same subnet mask. And basically configure this 5.2, 5.3, 5.4, 5.5, 5.6. This another network, 5.2, 5.3, 5.4, 5.5, 5.6. The same subnet mask for all. Very good. Okay, the table is complete. Configure IP addressing for the servers in rack 5, both interfaces. Okay, go to rack number 5. Server 1, rack 5, server 1. Desktop IP configuration. Use all this configuration. One 172.16.5.1.1. Subnet mask, very good. Default gateway 172.16.0.254. DNS 172.16.1.1. Fast Ethernet 1, 10.16 rack 5 server 1.1. Subnet mask 255.255.0.0. Default gateway 10.16.0.254. DNS server. Okay, don't worry about this. Packet tracer will use a default gateway of the fastest functional port. Okay. DNS server. 10.16.1.1. Okay, all this configuration. Okay, and rack 5 server 2. IP configuration fast Ethernet 0, 172.16.5.2, rack 5 server 2 1. Subnet mask, okay. Default gateway 172.16.0.254. DNS server, default gateway, okay. 172.16.1.1. Fuzzer the node 1, 10.16.521, 255, 255.00, default gateway, 10.16.01, 0 to 54. Okay, DNS 10.16.1.1. Okay. Next. Okay, all according this addressing table. Configure the display name and hostname for the switches in rack 5. Click the first switch in rack 5 and then Config tab. Okay, this is rack 5, first switch, Config tab, and DC1 rack 5 switch A, DC1 rack 5 switch A, very good. And hostname DC1 R5 underscore switch A. Okay, and you can do this here or on command line interface. I prefer command line interface. Enable configure terminal, config tab, global configuration mode. The hostname is case sensitive DC1 R5 underscore switch A. Enter. Go to config and very good. The second switch, verify the display name is very good. Okay, very good. DC1 rack 5 switch B. Go command line interface. Enter. Enable configure terminal. The hostname is DC1 R5 switch B. Okay, DC1 R5 underscore switch B. Enter. Okay, very good. You can verify. Very nice. Connect cables for rack 5 equipment. For each server, connect copper straight-through cable from the fast Ethernet 0 to correct port on DC1 R5 switch A, and a straight-through cable from fast Ethernet 1 to DC1 R5 switch B. Okay, already connected all these connections to the servers. Connect a copper straight-through cable for the fast Ethernet 01 port on DC1 rack 5 switch A to fast Ethernet 23 port on DC1 master switch A, fast Ethernet 2 on DC1 rack switch A to fast Ethernet 24 DC1 master switch A. Okay, these two connections, this and this another. Okay, right click, unmanage all cables. Now you can see the connections to the master switch from this switch, DC1 rack switch A to master switch. One goes to 23 on master and fast Ethernet 2 goes to 24 on master. In the same way for the another switch, the connections to the master. Okay, these connections 23, 24, 23, 24. Configure LACP between DC1 master switch A and DC1 rack 5 switch A. Okay, these are the configurations. And now start with the master, DC1 master switch A. Configure ports 23 and 24. Click here. Click on the switch, command line interface, enter, enable, configure terminal, interface range for Ethernet 23 and 24. Okay, configure ports strungs, switch port mode trunk. Okay, switch port mode trunk and recommends native VLAN 99 for the native VLAN. Switch port trunk native VLAN 99. Enter. And assign to channel group number 6. Channel group 6 mode active for LACP. And use no shutdown. No shutdown. Then exit. Go to another side, the ports 1 and 2 on DC1 rack 5 switch A. Click here, command line interface, enter, enable. Okay, it's already on global configuration mode, so enable is not necessary. Global configuration mode, interface range, first Ethernet 1 and 2, switch port mode trunk, switch port trunk native VLAN 99, and okay, port consistency restored, and channel group. On this side, use one mode passive, enter, and no shutdown. Okay, all these configurations here. Repeat the above to aggregate the appropriate ports between DC1 R5 switch B and DC1 master switch B. Okay, go to another master switch, DC1 master switch B, command line interface, enter, enable, configure terminal, interface range, first Ethernet 23 and 24, switch port mode trunk, switch port trunk native VLAN 99, channel group. Okay, again enter channel dash group 6 mode active, enter. Okay, interface range 23 and 24, switch port mode trunk, switch port trunk native VLAN 99, channel group 6 mode active. Okay, channel group 6 mode active. No shutdown. Enter, no shutdown. Okay, and go to the another side. DC1 rack 5 switch B. Enter global configuration mode. Interface range, first Ethernet 1 and 2, switch port mode trunk, switch port trunk native VLAN 99, channel group. Okay, again channel group 1 mode passive, enter. The channel group 1 mode passive, not shut down, enter. Verify the ports. Okay, for example, DC1 ROG5 switch A, enter, and show their channel space summary. What protocol is port channel 1 using for link aggregation? LACP. Which ports are aggregated to form port channel 1 on DC1 ROG5 switch B? Okay, go to DC1 ROG5 switch B and show the channel summary, enter. Okay, the answer, which ports are aggregated on DC1 R5 switch B, fast Ethernet 1 and fast Ethernet 2. Record the command used to verify show Ether channel summary. What is a data center? A data center is a physical facility where corporate computers, network, storage, and other IT equipment that support business operations reside. The computers in a data center contain or facilitate business-critical applications, services, and data. Many organizations have multiple data centers based on geographic and business requirements. What benefits does a data center provide for an organization? A data center consolidates IT resources, allowing centralized management, optimization, and maximum utilization of resources. It minimizes unnecessary duplication and wasted resources. Why is redundancy important in a data center? Redundancy is used to eliminate a single point of failure and maximize data center uptime. What elements of data center should incorporate redundancy? All components in a data center should incorporate redundant design principles. Servers and IT devices should incorporate redundant components such as power supplies, hard disk drives, and memory. Servers and network devices such as switches, network cabling, power feeds, and cooling should also incorporate redundancy. Network technology that incorporates redundancy such as Ether channel and HSRP should be incorporated whenever possible. What is the importance of Ether channel in a data center environment? Ether channel allows multiple physical links to be treated as a single channel and treated as a single instance of STP, thus combining their bandwidth. It also provides for redundancy, so if one link in an Ether channel bundle fails, the others remain active. Okay, completion 100%. Thank you very much.